Yeah, that's it. Hello, hello. Hello, hello. Yeah, we'll be fine now. Sorry.
Cool. All right, resuming. For those that didn't hear me on the stream earlier, basically, my name is Patrick, and I am in the BSc department. Okay, it's all changed recently. This is kind of.
Hello, hello.
Oh, now I can hear myself coming back from the
Hello, hello.
speaker
Yeah,
here.
we'll be fine now.
How do I mute the? Okay,
Sorry.
It's just playing back everything from the stream, delayed sound.
All right, resuming. For those that didn't hear me on the stream earlier, basically, my name is Patrick, and I am.
You got immediate feedback.
Well, slightly delayed feedback.
Oh yeah.
So yeah, recently we've had a bit of a org structure. This is org restructure, should I say? That red box is BSS. That's kind of how everyone has thought of us in the past, or we've been called many times. It's just BSS, which is our main application that we've done over the years. We now been moved under content platform under Graham Fowler, who I think he's underneath Patrick Massini, who's I can never remember all the different departments, but yeah, we are now under Lawrence Smith, under the content scheduling. So we've been moved around, and we were called broadcast software engineering, like I said before. But we're actually now, just recently in the last 2 weeks, been given the new name of Content Scheduling and Enrichment. I think it's been very difficult for them to kind of put their finger on what we actually do as a department. I think kind of because of the history, we've done support of broadcast. To start off at the very beginning, I guess support is the only name you can really give it. We help a whole lot of back-end users basically just make sure that broadcast runs, and we've used software solutions to kind of help them along the way. But because we've touched everything around broadcasts in some aspect, we've helped them here or there. We've got like lots of different functions throughout our real estate. So they kind of struggled with the name, but eventually now we're kind of scheduling and enrichment. But to be honest, we probably have a lot of applications that do more than just that. So yeah, been around for 15 years. The departments, when I say we have, it's more that we have one or two individuals that have been here since the beginning, since the inception, and they've always just stayed within our department. So I don't actually know when Sky started, but it was 15 or so years ago. And originally it was just around the linear and and like media management. So getting all the actual media files from the studios and the preparation and then the linear scheduling and all that. But I'll get into that more in detail with the domain overview later. And now we're doing in our departments, a lot of the recent work has all been in the VOD, the on-demand kind of area, and then also a lot to do with ad sales and the ad smarts work. So we're around 100 people. I just went through the distribution lists the other day, and it's about 90 something, or it goes up and down all the time. But it's about 36 developers, then 28 testers, then we've got our Scrum Masters because we try to be agile, and we just, in our teams, got a lot of analysts, a lot of just support users who actually know the most about our department, and a lot of the guys that have been around for the longest are all on support, really. We've got Oracle DBAs, we've got some DevOps, like Alex over here, and then I don't know how many managers that tell us what to do. Where we're in Sky Central now. We're lucky enough to be moved there. I think it's to keep us quite close to the users that we support, and we're in Zone 1.4. So getting into the domain overview, kind of what we actually do, it's best to kind of, I've got it mapped out in almost like the workflow or the flow of the data that we actually support, all our systems move around and support. So to give a quick overview, it starts off with acquisitions, which is the lawyers and the data entry users that basically capture the deals with the studios, saying that basically we can show this content on these platforms for this period, and all that kind of information and all the nuances around that are captured through, for example, BSS or rights logic. From there, a whole lot of different other workflows kicked off once we've actually got a deal. Media management kind of decide to contact the studio now and actually order the material that they want to show. Then they start prepping it, doing a lot of, when they actually get the file, get it ingested into the MAM, all these other things, cutting it up and deciding what ratings it's got for compliance, a whole lot of things. At the same time, schedulers and planners get hold of the rights and they decide that actually in 3 months' time they want this channel to be showing that, or they want this to be on the VOD catalog, and they basically schedule different availabilities for that. Once the media is actually ready to be broadcast and it's getting closer to the actual broadcast date, the media and the schedule gets sent to linear playouts, as well as the EPG gets a whole lot of the scheduling information. On the VOD side, the same files we've got whole systems for prepping and kind of orchestrating, talking to a whole lot of other systems, getting the content prepped and ready to get onto the catalog and the CDN. Various different CMSs downstream, internally and wholesale, a whole lot of different CMSs. So that's kind of an overview of the different contexts that we kind of touch throughout our department. So a little bit of the department history, so a bit about how we've actually gone around supporting all these things over the years. Multiple systems, which, like, I guess when the Sky started, there was lots of off-the-shelf kind of systems they might have used, a few custom tools. I think because Sky was actually quite leading edge when it came to satellite broadcasting, so there wasn't necessarily tools that actually fitted the job. And at one point, the decision was made, as far as I heard, can I understand, from like 10, 15 years ago, the business decided it would be much nicer if there was one tool that just had like an end-to-end view of the whole kind of process that I was showing before. I don't know if that was a good decision or not, but the users, they were just sick and tired of having to go in and out of lots of different little applications just to get one task done. The original application called BSS was this master kind of application that was going to give them this end-to-end capability, and it was written in a language called Magic, which is for those of you who've ever heard of it, I don't know if many of you have, it's a 4th generation language. It's really basically a rapid development language that just kind of allows you to connect to a database and quickly like draw up a nice UI and allow users to capture data really quickly. And it's just a fast tool. So they were actually able to do a lot of this end-to-end journey quite quickly and develop it all quite easily. And then it's all sitting on top of an Oracle database. So about, I think it was, I actually don't know how long ago, 6 or 7 years ago, they decided that Magic developers were too few and far between, expensive, and it was time to get off a bit of a dying horse, I think. And they found a solution, can't remember who it is, but they have a product that converts Magic to C# using this Firefly framework. And it's basically like a WinForms version of the original Magic application. So this was great. They could now hire lots of .NET developers to come and support the tool and keep it growing. And that's pretty much when our department transitioned into really using the Microsoft stack, getting a lot of Microsoft developers inside, and it kind of got us in the direction where we are today. Then 6 years ago, kind of started doing VOD PDL. After a few years, they realized, and that was all done with like Oracle and stored procs and stuff. They realized that the VOD services need to be kind of rewritten because there was huge new projects like Sky Store that they were struggling to get done in time just by writing Oracle's procedures, and it was really difficult to test. So they decided to rewrite it as .NET web services and do a lot of orchestration and through that with queues, proper active MQs and things. And then 1 year ago, we also started a transformation project, was to really start stripping out of screens, out of BSS, or to prove that we could. This monolith that had become, and it was very difficult to actually change anything in BSS. It took too long. So there's this transformation project kicked off, which I was involved with. And then recently, yeah, we've been moved to be part of the greater software engineering department and under content platforms. Technology overview. Like I said, we started off mostly in Oracle and PL SQL. There's a lot of code still today done just in Oracle PL SQL. We do C#, .NET Frameworks 4 and 4.5. We've got a lot of WCF services written, Web API RESTful services now mostly. Like I said, BSS was converted to WinForms application, and we've done some WPF screens in there to make it also easier, as well as some other WPF Windows clients. Latest thing we did in the transformation project was starting to write some more single-page applications, web apps, should I say, using actually already there were a few new applications done with Knockout before transformation. Then in transformation project, we decided to do it using React instead. Once again, when the VOD services mostly run off ActiveMQ, Windows services reading off those queues and orchestrating a whole things. And then we do a lot of automation to try improve our automation testing, so I say, to improve robustnesses and resilience, or just to stop regression and breaking things as we change things. We do a lot of the Python tests for our web services, and then QTP for tests for our UIs or our Windows client UIs, mostly just BSS. And then what Alex will be talking about soon, DevOps, use mostly TeamCity, OctopusDeploy, and Chef. And there's a kind of a makeup of the 36 developers, kind of how much each of them knows in these different languages. And then finally, just to give you a bit of an idea, we've actually got like tons of individual deployable components, but this is kind of I've grouped a lot of them into kind of larger kind of contexts. The ratio isn't quite proportional, but the one in the middle should be way bigger than the rest in terms of lines of code, and that's the original BSS app, which started at the beginning, which has been converted from Magic to C#. So of that 1.5 million lines of code, a lot of it is kind of boilerplates, automatically generated code, and then a lot of the logic was originally written in PL SQL, because Magic, you didn't really do so much business logic in the Magic. You would actually do it in the database itself. So, and then we've got Vodcast, which was transformation project, the VOD services that I was talking about, a whole of the EST, which is Sky Store, new rights projects that we've been trying to do for the last 5 years. Then there's AdSmart and media sales, as well as a whole lot of the kind of enrichment side of things where we're talking about now, is part of where our department is called content scheduling, which is a lot of the top services, as well as the enrichment, which is the thumbnails and the listings. And that is a quick overview of our department. I know there's probably, I could talk for a while actually, but let's see if there's any questions. Anyone want to know anything about our department and why we're so interesting? Yes, Harry.
How long did the migration take to convert to C#? How long did that whole process take?
So the question was, how long did the BSS Magic to Firefly conversion take? I have no idea. I was not around for that. 1 year. Yeah. So there's it's an Israeli company. The actual, like, yeah, I would imagine.
It took 17 years of development, put it in half an hour, and converted it out, and it ran first time. They converted on a laptop as well when they came out. Obviously, there were things wrong with the screen. That's right. But
So,
within half an hour, the whole system was converted.
okay, so for the guys on the stream, it took several months to get it all kind of aligned, but the actual passing of the code took 30 minutes.
They got a child prodigy. He became a qualified doctor, and then a PhD in computer science. And he got bored of surgery and started to write this engine.
Okay.
He was 15 years old when he was coding in Israel for the defense forces. When he was 15.
Wow.
That's right. So just to put 5 million lines of code into perspective, I seem to remember that's about the size of the code for the Windows NT kernel, and also for Microsoft Exchange. So that's a pretty big development.
Yeah. Any other questions?
So is there a date when the actual BSS C# application gets switched off?
The BSS application gets switched off. I don't think it'll ever get switched off, personally. We are trying to decommission screens, but they are still around. Like, it takes a long time to take one screen out there. So what it probably took like a few weeks for one developer to write in the first place will now take months to decommission. And it's difficult. We're getting there. Yeah, I mean, I don't really know the visions so much, but I feel like a lot of the data entry stuff isn't changing that often. And that's what BSS mostly does, is data entry. A lot of the automation and orchestration of workflows, that stuff gets tampered with all the time, and it's not really in BSS as such. It's in another product called Messenger, or the VOD services. And that's really where the change is now, and where the interest is to spend money. But the actual capturing of information, it will slowly get changed, because it'll take a long time to rewrite some of these screens. Anything else? Otherwise, I'll hand over to Alex for the next talk. Thanks, everyone.
Right, well,
Good question.
Yeah, it should be open there. Oh,
okay.
I closed the Chrome, didn't I? Oh no.
In the middle.
It just needs to...
Oh, perfect.
Let me kill this thing and show. And then let's move it. Is it moving? Is it moving?
Not yet.
Plus my cursor.
Yeah, you still got the PowerPoint up there.
So what is going on? How is it to Windows now?
It's still there.
Maybe I'm moving it to the wrong side.
Oh, don't worry about it. I'm wondering if possibly maybe the Word document would be better. I don't know. We could try it. Oh, you've got it down to the back. No?
Let me kill this thing first. Yeah, and then it should be here and to.
Oh, yeah, yeah, exactly. It's working.
Where's my cursor now?
It just doesn't like it, does it? So you're somewhere. No, that's just the audio.
No, it went to the other side.
Yes, that's it. You got it. Let's make that a bit bigger. Perfect.
Sorry, the streaming thing cannot handle mirrored screens, so you will have to, like, if you need to click or scroll.
If you don't, sorry. Well, in that case, just as well, I printed it out just in case because I'm afraid I won't be able to read it. That's fine.
But you can just scroll like this. That's all you need.
That's perfect. Thanks very much. Right.
But you probably just need it on. Yeah.
Right. Perfect. Okay. Not that. Let's try that. Right. Okay. Right, so I was just going to follow on from Patrick's talk. I'm also from content scheduling and enrichment. I always have to remember that one. You probably saw in his list there was he had a breakdown of how many people were in the department. He had the developers, the testers, and it went down in decreasing numbers. And then it had DevOps, and it had 2 out of 100. Well, I'm one of them, so I'm sort of one of that 2%. And then there was the murky waters of the project managers. It was just a question mark, that totally unknown. So I wanted to tell you a little bit about how we do build and deployment here. I joined Sky 9 months ago. Prior to that, I've been a build manager in various financials. I've also worked at the BBC. And when I came here, I can't take any credit for what we're doing with what we call the release manifest. This was already in place when I came here. What I wanted to say, though, was I hadn't actually come across this idea before. It seems to work really well for us. I really like it. And I just wanted to share it with you and tell you sort of why I think it's good. So let me just go through this. All right, I'm going to have to read from my sheets, I'm afraid. So first of all, really, two major approaches to build and deployment. Typically, you either do a release-based deployment or you do a patch-based deployment. They both got their pros and their cons. I didn't really think there was an awful lot outside the release space beyond those two approaches. We've got something different called the release manifest, so I'm just going to get straight onto that, which is down here. Okay, so a release manifest is a way of organising projects in a solution such that they are versioned individually, but they're released as a collection. So it's distinct from a source code tag or a branch because it typically doesn't refer to compiled binaries. So it does refer to compiled binaries rather than source code. And it doesn't necessarily include every component in the repository. So it's not simply a tag that you've applied to the repository as a whole. So because of those characteristics, it has aspects both of the a full release and also of a patch. And I think it incorporates strengths of both approaches and avoids some of the problems. So first of all, I just want to go over a few of the obvious things that you achieve with this, and then I'll sort of show you how it actually works. First thing is you only deploy what's changed in your release. You don't do a full release. You don't just release one component. You actually release deltas basically. The second thing, which is slightly odd about it, is that our releases are environment aware. In other words, this is much more like a desired state configuration approach to deployment than a sort of static state. You can sort of think it's more like MS deploy than say like MSI. In other words, what you deploy will change depending upon what environment you're deploying it into, because it'll have a look and say, I don't need to change this bit does need to change. Put it in a different environment, you'll end up with a different set of components being deployed. Third point, minimal issues are found during integration testing for the reason I've just mentioned, namely that the release manifest is all about early integration. In fact, from the earliest possible stages of development. So in our case, we actually start testing, or we start deploying with the release manifest as soon as code gets onto the developed trunk itself. In other words, as soon as people have code that's ready to be merged into the branch where it can be tested alongside other code. All right, let's have a look. So at a very high level, it really isn't very complicated at all. The manifest can be anything. it would probably make more sense to use a JSON file. We used XML. It's simply a versioned product. We have one version at the top there in release manifest version, and then inside it we have a set of components. They've got names, could just as soon be GUIDs, and they've got a version. That's it. There's nothing else to it. That's the data part of it. But there's also some business logic that goes alongside it. So I've then got a little piece of pseudocode here that shows you the deployment code, which is very, very uniform. It just says for every component there, is the version in the target environment the same as the version in the manifest? If it isn't, then deploy it. Otherwise, skip it. And that's it. You know, very, very simple. It treats all the components exactly the same way. And then finally, probably more importantly, the code that actually gets that manifest generated and updated in the first place. And that one basically says, build a component, stamp it with a version in your CI system, and then this little bit of logic kicks in and says, did I build it from the default branch? I'll come to that in a moment, but the main thing is we're only using this logic for deployments from our default branch or our release branches. So when people are working on their feature branches, they don't need to get involved in this process. They can do what they want. They can release their stuff individually to their environment without integration testing, which is the way that you're likely to want to develop. So did I build it from the default branch? If it's yes, then is this a component that is managed by the manifest? And if it's yes, then update the manifest with the version that I've just built. And that's it. So this document will track over time the latest versions of components that are intended to be released in the next major release. So what problems does it solve? Let's scroll this down. A second. Okay. Right, feature-based and vertical deployment. I'm not sure that's so much the case in Sky, but I've sort of seen another place I used to work where this sort of thing would have been very useful. And that's basically where we used to work in feature teams. So you'd have all the people sitting together for a feature. This would be the back-end developers, it would be the UI, it would be people working on the API, the middle layer. And they all wanted to deliver code which would go into the same release. So they had a stack of components in different languages, all of which had to go together. The versions had to be kept in sync. And it was a bit of a nightmare because we didn't have this idea of release manifest. So you can imagine it was just complicated keeping the stuff in sync. A manifest is perfectly suited for something like this. So it allows you to treat a collection of components as a single entity. Minimal deployment package. Well, the nice thing about this is the release manifest is a funny sort of entity because it's almost a form of package in itself. It's not a formal package. It hasn't actually got the content of those components, but it's stating what the dependencies should be among them. So in this case, what we said is it's capturing the state of all the components in the solution, and the responsibility for determining what's changed is devolved to the manifest itself. It's no longer a decision based on deltas between branches within the source code repository. Okay, so it's literally you're just comparing the versions and saying, is that what we've got? If so, we don't need to deploy anything. Next point, the release manifests an effective baseline, environment baseline. This was a side effect I hadn't really thought of about it. I've got here, we can add simple logic to the process that parses the manifest so that prior to deploying any component, we first check whether previously that component is already deployed in the target environment. The release manifest thus supports us in 3 different ways. We can update a production environment with only the components that have changed. At the same time, we can re-baseline any test or development environment by reverting older or newer versions of anything we find that doesn't match the manifest. And finally, we can deploy a full environment completely from scratch, because if none of the components are there, then the manifest ensures they all get deployed. So it achieves 3 different purposes, simply utilising the same logic. And the final point is that the version unit's binary. You don't have to use a release manifest if binaries are what you want to version. I personally think this is rather a neat way of doing things, and our release manifest works on the basis that each of those components is actually a NuGet package. It doesn't try to hook into source control and rebuild anything. It says this stuff's already been built, it's been built once, and that's what we're going to go to production with. It's exactly the same stuff that went through our CI environment. So let me move on to a little bit more. I've got a few diagrams because I thought they might be a little bit more clear. I'll scroll down to here. Okay, how BSS works with a release manifest. Patrick's already touched briefly on what we used, our tool chain. I guess I'm repeating him a little bit here. We use .NET for application code, user interfaces React.js and Knockout.js, test code a variety of languages including Python and MS Test, VS Test. CI, we use TeamCity. and we use build templates to standardize the way that stuff is pulled out of source control, versioned, built, and packaged. The build tool we use is psark. There's obviously a kind of overlap here. psark is a fantastic third-party PowerShell framework that simply allows you to build typically Visual Studio solutions in a consistent way. So it lets you hook in test, package, build, I think coverage steps and a number of other things. So the main thing is you don't need to try to furnish a separate build script for everyone's solution. You can just say switch on or off the features of the psark that you want to use, and more to the point, we can then abstract the common functionality into a single TeamCity templates and say, you just need to hook your solution into this template and psark will do the rest for you. So it's really, really good. And then we use, for continuous deployment, indeed just for deployment in general, we use OctopusDeploy, and we use OctopusDeploy with NuGet packages, which is kind of how it's designed really to work. You don't have to use a NuGet package, but you're not leveraging its usefulness fully if you don't. And then I've said we've got a number of environments. So this is really to show how the release manifest has kind of sort of infiltrated our processes at quite a deep level. First thing is temporary environments. We spin these up. I'd love to give a talk actually on how we do this with Chef, but I can't do that today. But we basically use Chef to provision some virtual environments and populate them with all of the components that we need so the developer can start developing on them and testing his code. So what we actually use is the release manifest from the previous production release, and we use that to baseline these temporary environments. So all of the components that are currently in production will be pulled in as part of our automated build, and they'll populate this image that we then give to the developer. So obviously these are temporary environments, they're supposed to last about a month. Over the course of that month, the image will be getting more and more out of date, which is why we say that you shouldn't hold on to these environments. You should get rid of them as quick as possible, and we'll give you a new one whenever you want. They take about 10 minutes probably to provision. A continuous integration environment. Our CI environment, at the time of writing, it used to build twice a day, and it would use the release manifest as well to work out what needs to be deployed. So it would pick up all of the deltas that were in develop, and it would use the release manifest to actually push out those components that had changed. So it's a nice consistent way of deploying. And well, I was going to say finally, actually, bar the production deployment, we also have fixed environments. These are to be contrasted with the temporary ones just because they are static environments. They serve different purposes. We have an end-to-end environment, for example, with a complete set of external interfaces. NFT environment, which has a similar architecture to production. It's a clustered environment. Various regression environments, and also environments where particular teams perform specific integration activities. The main thing is we can use the release manifest to deploy to all of these, including production, despite the fact the environment topology is different, and despite the fact the versions that even have been tested in those environments can be different. They can, we can use it for the production support environment. We can use it for, a previous environment, a demo environment. It doesn't really matter. They can all have different builds or different releases at the same time. So I'll just show you a picture. I think this one is pretty self-explanatory, but that's no, let me scroll it down a bit. Don't know if I can make that any bigger. If you can't read it, I think it's probably easiest if I just go and summarise it in the text below. The main thing is it's showing you the main interactions between TeamCity and Octopus. The key thing really is that TeamCity does the building, Octopus does the deploying. The link between the two is a version number. We make sure that the version that's built is exactly the same version number that is applied to the NuGet package, and this is what we use to link up the pieces of code when we say what is it we're actually going to deploy using this release manifest. Those are the component versions, those Octopus NuGet package versions of what appear in the release manifest. So let me scroll that down. Right, okay, so this diagram drills into our setup in a little bit more detail. It shows how we abstract common build tasks. I beg your pardon, let me move on to the next picture, which is a little bit more detailed, and the last picture here. This one, right. Is there a way to make this a little bit bigger? Oh, thank you. Gosh, technology. Sorry. Whereabouts is it, Patrick? Warm? Cold? Up here? Gosh, I could just see. Oh, is that it? Oh, come on. Let me try again. Right, okay. Is that better? better. Let me just scroll this down again. Right, okay, here we go. So here's the picture in all its glory. There's a lot of stuff going on here. It's probably too complicated, but I just thought it's the best picture I've got that kind of captures, I suppose, captures some of the complexity of what we're doing with Octopus and TeamCity. It shows how we're using build templates to an extent. It shows how we're tying the versioning between the builds and deployment. I can point these different aspects out. It's probably best if I go through quickly in order. How we abstract common build tasks into a generic build template and we share across the both different projects. If you look down the steps on the right hand side of that picture, I think you can see, probably better than I can, what it actually is that we're doing here. How we're linking the builds with a NuGet deployment package with the same version, which I've just mentioned. How we avoided merge conflicts in the release manifest. We put the manifest into its own repository so that we'd like you to have minimal issues with merge conflicts. It doesn't mean they don't happen, it just means that it's easier for us to fix them because the release manifest is not something that's going to be updated that regularly. I mean, you're unlikely to have every component in the release manifest at any point in time, and you're unlikely to be having a lot of builds successively on the developed chunk because your code should have stabilized quite a bit before it gets that far. How we structure our projects within TeamCity. I was just going to say we have a little convention here whereby, specifically if we just pick the deployment section, I think you can see there, all right, this isn't really illustrating it particularly well, but we use a particular convention whereby the project name in TeamCity will become our environment name in Octopus, and the build configuration name in TeamCity will become the process or the project in Octopus that gets deployed. So we're able to essentially, we know exactly how our build is going to link up with our deployment. It's just a nice convention to follow. How we use build triggers with branch filters. We've got a build. It's probably difficult to see, but we've got some build filters turned on there, which basically ensure that we only trigger updates to our manifest from the develop branch. We have a similar filter for the release branches when you're making a hotfix. And I think I'll stop there. I hope that made some sort of sense. Has anyone got any questions? Yep.
Why is it not just good enough having branches and tracking like what needs to be deployed to the branches itself? Why do we need a manifest?
You could do that. I mean, I think the manifest is. I think it's neater. I like the fact. Are you talking about versioning? Are you talking about versioning binaries still? Or are you talking about versioning code? Because
binaries are just a copy of the built copy of the source code. So whatever the source code has is surely the same as binaries. So the release manifest is just a copy of the code in the different branches.
Well, okay, it's a reference to the code in different branches. It is. I mean, I'm not saying there's anything magic about the manifest. I mean, its logic is extremely simple, but I think it's an incredibly good way of organising and collecting together different components. I mean, as an example, I'm kind of contrasting it with a bad build situation I saw before, not here, and this was where people had a lot of features in a large application they could turn on and off. I mean, it wasn't so elegant as toggling, the way I know we toggle features on and off in production, but typically they'd have, say, you could have hardware encryption in some environments, you could have software encryption in others. So they want to build these assemblies so that they can support both, but they'd only want to deploy one set of them. And then there'll be components that actually had dependencies, depending on whether it's a hardware or a software encryption. Those had to be obviously packaged at the same time. What they actually ended up doing was they built absolutely everything together, and then they tried to have sub-builds that would pull in the components that were relevant. Didn't help that it was all strongly named as well, which meant that as soon as someone also one assembly, it would no longer, it would no longer work at one time with any of the other ones, and it was all a complete nightmare. I'm afraid I looked at this, I couldn't really work out a way to fix it. I kept on saying, can't we just have lots of separate builds? And he said, well, number of permutations of hardware encryption, software encryption, endpoint simulation, no endpoint simulation, stub database, non-stub database. We haven't got that many environments, so you can't. And we just kind of live with it. This is what we should have done. So. Anyway, so thank you very much. I'll leave it at that.
Okay, one more. Rob will talk about TypeScript. It'll probably be short.
Well, we have 10 minutes.
Lightning talks when it's lightning.
Yeah.
No, that's cool.
I was just
was kind of last minute anyway. So, and when Dave told me, I was kind of worried. So I was going to be talking of evangelizing the benefit of types for room for C# developers. So I thought it's going to be preaching to the choir a bit, but coming from a JavaScript background, had types before, and the introduction of a type system and clever type inference has made our development a lot more pleasant and a lot more confident as well. So
you sent it on. Where did you send it?
I just sent it to you.
Is this it?
Yeah. To be honest, the PowerPoint isn't even that much necessary. I was going to just flip through it.
Oh, okay.
It looks pretty. What I need really is terminal and code.
Oh, that's going to be difficult.
Really?
Yeah, because the screen mirroring doesn't work with the streaming thing very well.
Can I have a terminal? You don't have
Yeah,
to
you
see
can,
a terminal.
you
But can you show code up on the screen?
Yeah, I can, but I'll terminate the stream then. Do you want the slides or not?
Yeah, sure. Go over the slides quickly. Cool. Lightning talk. TypeScript. So TypeScript, what is TypeScript? If you don't know, it's a superset of JavaScript. So it offers all of the features that JavaScript offers. So any JavaScript code is valid TypeScript code as well. It offers up to ES6 and beyond. So if you propose features of future JavaScript. So static versus so I've actually borrowed these slides from a training course we did on a day. You gave them to me. I borrowed. So there's a few differences obviously between static and dynamic. I think we know this. JavaScript is dynamic, whereas TypeScript is static typing. Some of the features that TypeScript gives you. The main one obviously is static typing. It's in the name, is what it is. I mentioned it gives you all a few future features of JavaScript. Interfaces, although not interfaces you might know in C#, there are some slight differences. And some of the joys of IntelliSense and syntax checking in your editor of choice. Which are shown here. There are a few editors here that you can use. The most common one for TypeScript is Code, Visual Studio Code. I believe it's first-party support for TypeScript. It's quite nice using Code and TypeScript. A few basics of TypeScript, what it adds to JavaScript. Obviously, type annotation. Has all the basic types like booleans, numbers, strings, things we're all aware of. Some more, so there's a difference between the different ways of declaring variables. In JavaScript, ES6 has become standard. The difference between let versus var and const. I won't go too into depth about all of that stuff. If we've known JavaScript, we'll know that, but it's not really useful in this talk. Type inference, object literals, ES6 objects. I'll whiz through this. I want to get to code quite quickly. Yeah. Let's get straight to code, okay? So I can demonstrate exactly some of the benefits. You don't have to create a project.
Yeah, no, I'm not. I just want to switch the screens.
But
So
how comes I can't mirror this?
I think the stream will actually blow up. But yeah, you will see. Just see what happens.
Just create a new folder. No, like a.
Oh,
No.
You might want to open something else. Or you can actually use this as an example.
Hold on. Oh. Where did the terminal go? I'm not really doing anything here. So I've just created a folder called test. I'm gonna simply start a basic JavaScript project using npm, which is no package manager. It's just like de facto package manager for JavaScript, really. This is just boilerplate stuff. And now I'll open this folder. Cool. Now the first thing that we need, hold on. The first thing for TypeScript is it relies on a tsconfig file, which is tiny up there. What that does is it basically tells TypeScript. Is there a way of zooming in? Where's the settings? Wow. So yeah, so what the config file does just gives you a few options. It tells TypeScript exactly what it needs to do with the code to generate into JavaScript. There's just a load of options when you're going to be developing. They've got a nice page with all the different compiler options, but it also gives you IntelliSense while writing the options to give you an idea of what's possible. So at the moment we're targeting ES5, which is kind of like the most regular old school JavaScript. So what that means is that when you build some TypeScript, when you have TypeScript and you build it, it will compile it and transpile it into ES5 style compatible code. So it'll run on almost any browser. So if I start a new, if I just create a new file, call it index.ts. Right. So we have a TypeScript file. So what do I want to talk about? Let me see. Right. So first of all, we got types. So we can have things like, as I said, let test be of type string, that sort of stuff. Okay. So test is now a string. If I then set test to something like that, the editor will immediately complain because, as I mentioned, it's a statically typed language. Okay. So now we have just emphasize that now we have within type is static typed. We're doing JavaScript. We're adding static typing to JavaScript, which is kind of cool because it means you add some sanity. You're not going to be able to change your variables willy-nilly. The difference is when you can then. Another thing about TypeScript is it does a lot of type inference. If I just declared that variable to jam, if I then try to change it to 10 later on, it doesn't work because TypeScript knows immediately that I've set it to a string, and therefore test as a string, right? So it can't change. The exception is I can always, because we are still, you got to remember, with everything in TypeScript, it's still JavaScript. So you can still do everything that you would like to as JavaScript, but within the TypeScript world. So you're allowed to have some kind of exception. The way you would do something crazy like this would be to then change this type to something which is known as any, the any type, which is what essentially everything is in JavaScript, it's any. So that's what we can do here, and then the editor will just say, okay, I don't know what this is anymore, I'm just going to do some crazy things. Okay, so that's some basic stuff. Let's talk about an interface. Let's make an interface, an animal interface, why not? It will have a name, which is a string. It will have a walk method, which returns nothing, right? And let's make some classes. A dog class, which has a constructor. Ah, Jesus. Here's a little bit of syntactic sugar that you can have in TypeScript. When you give an access modifier within the constructor, it adds it. It's short syntax for having a public name on the outside and then declaring this dot name within the constructor. And then I can have, so of course I forgot to say that dog implements animal, and again the editor will complain because I haven't implemented the walk method. So of course I have here return. if I then copy this, say I've got a cat and a mouse. Okay, they all implement animal, fine. Now, in JavaScript, imagine you had like a load of classes. Again, I'm going to be preaching to the choir here, but this is quite a useful thing I found. Just the idea that you're able to completely rename methods on the fly across your whole project. Obviously, that's allowed now because TypeScript gives you that kind of type inference will transcend your whole project. So now it's moved, so I can add something like a bird instead of walk. Birds can walk, but generally, you know, they fly. Animals generally move rather than exclusively walk. So that's one huge benefit of type inference. One thing is, so for example, I don't have to say. I always go back to jam. I don't know why. And it returns jam. So, as before with the type inference, it doesn't just have to be when you're declaring a variable. Methods have type inference as well. So in this case, if I say let a equal jam, and then again say a equals 10, again it will complain because it knows that jam returns a string. Okay, so there's some nice things with that can be done with type inference. One of the things with interfaces, so interfaces actually aren't usually used in this sense. An interface is usually actually used to describe an object that you might be using with JavaScript. So actually one of the most useful things in TypeScript about interfaces would be stuff like typing your APIs, typing APIs you might be consuming. So you can you know exactly what objects you're using when you say you've called something from the server, and you know what the API is. You'll be able to then use that with it throughout your code. That's why actually we don't generally preface interfaces with an I animal. For example, let's make another interface. Just something. Then if you have if you made some kind of call, any kind of your regular kind of objects that you pass around in JavaScript, as soon as it matches that, kind of definition, that kind of structure, it's fine with it. So it's a bit different to what I understand about C#. One more thing that I would like to go over is well, two more things. There's also okay, cool. I was going to talk about the difference between interface namespaces and modules. Because that's quite a confusion, but I suppose that's a bit more deeper into TypeScript. One nice thing that I would like to emphasize about TypeScript is, again, going back to the initial point that it is just JavaScript in the end. So you are able to use all of the packages that you can have with a normal JavaScript project. So stuff like, for example, if I went back to my terminal and I npm install underscore, because why not? So underscore is just a general helper library. It's not really as useful anymore with ES6, I guess, but just gave a lot of helper methods for manipulating arrays, that sort of stuff. Initially in TypeScript, I won't be able to use it because the type system doesn't know about it yet, but you can then install something. So there's this definitely typed movement that types every single kind of library within npm. Now it's kind of associated with a lot of libraries are including their types within something called @types. So any kind of library, most of their types will be available from @type/library name. And so now, if I go back to my project and I restart Visual Studio because it seems that it doesn't pick it up immediately. When I look at underscore, now I have all the methods that are available to me from this library, which again, it just makes integrating with libraries, it makes developing in JavaScript a lot easier. It makes you're a lot more confident. You're not going to make mistakes. You can integrate with other libraries very easily, and it just speeds everything up. And in the end, actually, if I then show you, so there are no errors currently. If I then build it, TSC. So I built this just by running TSC command. It's a TypeScript command. You can see here now we have an index.js file, and here is ES5 ready, ECMAScript, normal old school JavaScript ready code. That is a translation of what we just saw in TypeScript, and this will run in most browsers. Almost any browser. Every. Yeah, except like IE6 or. So this is a very yeah, still went over time. Sorry. This was like a really rushed kind of very quick kind of overview of what TypeScript does, some of the benefits, some of the things that I like. I think the main thing is kind of TypeScript you should think of it more of as a developer aid, really, when developing JavaScript. It gives you a lot of confidence that you're not going to mess a whole ton of things up. You don't have to worry about your spelling because the editor will immediately tell you when you've done things wrong, when you call methods that don't exist. It's just kind of like real quick time checking that you're not, messing things up. And it also gives you a huge benefit when it comes to refactoring. And I think that all of those are really important. And it's a good thing for JavaScript. Anyway, yeah. So every so often we hold TypeScript training events. I don't know when the next one is going to be. It's a whole day event, so we get a lot more time to talk about lots of things. Are there any questions, or do people just want to get out for lunch, kind of thing?
Yeah. I mean, do you integrate this with Webpack or something?
Yeah, of course. Yeah, this is easily integratable with Webpack. There's a TS loader that you use to integrate with Webpack, and it works perfectly fine. Yeah.
So the last TypeScript was actually about React, Webpack, and all the JavaScript.
So exactly. So one of the things that I was going to mention was the difference between namespaces and modules. For example, namespaces in general. So if I had you can create namespaces. So if I just wrap this whole thing in a namespace, so that's kind of putting it within the test module namespace. You don't use namespaces if you're going to be using something like a module bundler. Namespaces in general are used for kind of more old school projects where the JavaScript files are kind of just concatenated together in one bundle JS file and then included in a script tag. And then namespaces give you that kind of like separation, as you would imagine. But you can just use, instead of namespaces, you can just use normal, more normal ES6 style. Actually, let me just undo. ES6 style, ES6 style imports. There you go, underscore. And now, once you include an import statement in your project, TypeScript will know that this is now a kind of like module-based project, and it works out. It stops you. It doesn't allow you to. So, for example, sorry. If I'm using namespaces, I don't have any import statements. Then when I go to a different file and I have something in the same namespace, whatever I can call it, it's fine. As soon as you include an import statement in your project, TypeScript will know it's a module-based system, and you can't just reference things from other files willy-nilly. You have to import them first. So it has quite strong support for Webpack and module bundles.
there's only like one downside I have, like as opposed to using Flow, and that is the object-oriented paradigm. Like from my experience, I've found that it's too easy to get caught up in like crazy abstractions. And I've seen abstractions where like business rule is an abstraction, and I feel like some stuff from like object-oriented languages can really limit like your capabilities.
Yeah, sure,
So,
but like I say, I mean, like I said at the beginning, the key point I wanted to establish is that TypeScript underneath everything is JavaScript. So it's up to you in the end if you want to employ an object-oriented style. TypeScript is perfectly fine using functional style programming, whatever. All it's doing is adding types to functions, types return methods, types to your APIs. You don't have to, if you don't want to use classes, you don't have to at all. You can still write all of your functions in your modules, don't have any class declarations anywhere, and you will still have the benefit of having types everywhere, easy refactoring, without kind of the shackles or whatever of what you, or perceived shackles of kind of class structure. Yeah. Any more?
Thanks. I guess we were discussing the channel. Let me stop the stream first. We were discussing the channel. What? How do I stop the stream?